Yo, what's up, guys? Welcome back. Episode 135 today, I think. Yeah, because we did 134 yesterday. I think we did, Vaporeon yesterday. We got a Jolteon today. It's probably my favorite evolution. But yeah, two things. I'm probably gonna record a video today. I'm gonna record a video tomorrow. They're gonna be probably fairly quick videos. Just because I'm quite busy. I mean, I work on a full-time job and everything, and I try and fit in a video. It's not like I'm kind of in school right now, where I have a little bit more time. I feel like to post a video, my schedule is kind of all over the place. But right now I'm working a 9 to 5, so it's kind of tough. But what was I gonna do? Damn. I was gonna lead into something else. Oh yeah, I was gonna lead another point. I feel like it's kind of cool to see that there's actually people that watch. Usually, like past how many episodes now? Probably about 130 days. We usually probably average like hour and a half, 2 hour long videos. But now that I'm doing kind of shorter videos, because it's like, tough with my current job. I'm working long hours that, to make a video, while also going to the gym and doing other things like. It's tough to make an hour and a half, 2 hour long video, and then I try and work on some side projects like spend half an hour like before I go to sleep working on something. So yeah, I appreciate that people watch and comment, and it's kind of cool to see that following along with my journey, and I'd also love to hear yours. So but yeah, probably gonna do one problem, maybe two if the first one's pretty easy. I don't know. But yeah, let's jump into this. Let's check out the Jolteon Pokemon sound. Ooh. I didn't even know how to do this, bro. Like, I don't know. It's some weird stuff, but anyway. Let's check out the problem of the day today. I think we're probably close to 450 problems, probably, maybe, something like that. Lexicographically smallest equivalent string. It's got nearly an 80% acceptance rate, so doesn't seem too bad. You're given two strings of the same length, S1 and S2, and a string base string. Okay. We say S1I and S2I are equivalent characters. For example, if S1 is equal to ABC and S2 is equal to CDE, then we have A is equal to C, B is equal to D. We say that S1I and S2I are equivalent characters. Okay. S1I and S2I are equivalent characters. Okay, so I think P is equal to M. For example, if S1 is equal to ABC and S2 is equal to CDE, then we have A is equal to C, B is equal to D. Okay, that makes sense. Equivalent characters follow the usual rules of any equivalence relation. Reflexivity, A is equal to A. Symmetry, A is equal to B, implies B is equal to A. Transitivity, A is equal to B, B is equal to C, implies A is equal to C. Okay. For example, given the equivalency information from S1, ABC, and S2, CDE, ACD and AAB are equivalent strings of base string EED, and AAB is the lexicographically smallest equivalent string of base string. Return the lexicographically smallest equivalent string of base string by using the equivalency information from S1 and S2. Okay. We can group the characters. MP, AO, K. The characters in each group are equivalent and sorted in lexicographical order. I think this description is confusing when I read it. I honestly don't really understand what the question's kind of asking me. I feel like it's like, maybe because I'm stupid, I don't know, like maybe this question is written good, but I find it extremely confusing reading it. Camera such information that the prompt description takes it away. Okay, so obviously it must be a little bit of a I said, thank God no more graph today. So young and naive. I like graph problems, bro. Need to study graph. Model these equalities as edges of a graph. Oh, it's a graph problem. I did not expect that. Union find. I did not expect this to be a graph problem. That's... Yeah, man, to be honest, I'm really not sure how to do this problem. I'm not really familiar with the union find algorithm. I think we're definitely going to have to look at a video for this one, man, because I'm not really too sure. Lexicographically small equivalent string. Fisher coder. Cheat code ninja. Maybe we'll take a look at this.
Hello everyone, let's solve a very interesting problem today. In this problem, we are given two strings and the characters at the same index are considered as equivalent characters. For example, at index 0, we have these two characters for a given words, so we have to group them together. Similarly, for our next index, we have these two characters, so we'll form a separate group for them. Similarly, for our next index, we'll group these two characters. And now when we go to the next character, we see that one of the characters already belongs to an existing group. So we'll add this pair of characters to our existing group. Similarly, for our next pair of characters, we'll form a separate group. And again, we see that one of the characters belongs to an existing group. So we'll make it part of the same group. So after going through all the pairs of characters, these are the 4 independent groups that we'll have. In our problem, we are also given a base string. And for each character in it, we have to find which group it belongs to, and then we'll have to map it with the lexicographically smallest character in that group. For example, character P belongs to our first group. The smallest character in that group is M, so we'll map our original character to M. Similarly, our next character A belongs to the second group, and A is the smallest character in that group, so we'll map it with A. Similarly, our next character belongs to the third group and K is the smallest character in that group, so we'll map it to K. We'll do the same thing for the remaining characters and this will be our answer. And if there's a character in the base string that does not belong to any group, in that case we can consider it to form a self group and it will map to itself. Let's try to come up with an intuitive solution for this. Let's see what happens when we encounter these two characters in our strings. The first thing that we'll do is to group them together. Since they are grouped, so any of these two characters, if they are in our base string, we'll have to map it to the smallest character in this group. So if we encounter M or N in our base string, we'll have to map it to M. Similarly, when we encounter these two characters, we'll have to form a separate group for them. The smallest character in this group is P, so for either P or Q in our base string, we'll map it to P. Now let's see what happens when we encounter these two characters. We see that the character N already belongs to the green group, so we'll add our other character to that group. Now A will become the smallest character in the group, so for any of these three characters, we'll map it to A. So we could also say that this group is represented by character A. Similarly, for these two characters, we'll update our red group and it will now be represented by character C. So we see that these characters in some way represent a hierarchy in which the smallest character in the group represents them. So when we encounter a pair of characters, we try to see if they fit into an existing group, and if the new character will be smaller than the head of the group, then it will represent the group. Now let's see what happens when we encounter two characters that belong to two different groups. So in this case, what makes sense is that we have to somehow merge these two groups into one. But the problem will be in determining which character will represent this group. Since A is the smaller character of these two, we'll represent all these characters in this group by A. So what we are doing in this problem is that we are placing each character into a group, and when we have to merge two groups, we check both the head characters of the group and whichever will be smaller will represent the combined
I'm
group.
still a little confused.
So
not
this
gonna lie,
problem
but
can be solved using a very common graph algorithm called as union find. This can be used to solve many problems where there's a group involved, and these groups have a hierarchy so that each element in the group can be represented by the parent of the group. And when we have to merge two different groups together, we find the parents of both these groups, and based on some conditions, one of these parents will be represented by the other one. We'll implement two methods for this. The first method will be the find method, which returns the root of its group, and we'll implement the union method, which will merge the two groups by changing the parent of one of them to be represented by the other one. The time complexity of this would be the maximum of the string lengths of the base string or our input string, and since we have to maintain the hierarchy for only 26 characters, our space complexity would be constant. Let's create a hash map to store the parents of each character. Now let's define our find function, which returns the root of the group for a character. The first thing that we'll check is if that character does not belong to a group. Then we'll create a self group for that character, so it set its parent to itself. For each character, we have to traverse up the tree, going through each of its ancestors to find the root character. And for the root character, the parent will point to itself. So if that condition happens, we know that we have reached the root character. So for going up the tree, our current character will now point to the parent character. In our case, the chain length can at most be 26 characters. But if we had more elements in this chain, there's one path compression technique where we change the parent to the grandparent. So the next time this lookup happens, we'll be jumping many steps to reach the root faster. This can also be done recursively so that all the elements in the chain will now point to the root. Since we have changed the parent to the grandparent, our current character will now point to it. And once our current character becomes the root character, then we'll return it. Now we'll define our union function, which takes in two input characters. We'll now find the parents of these two characters, so we'll call the find function on each of them. If both the root characters are different, then we know that we have to merge these two groups. So if our first root character is greater than the second root character, since we have to take the smaller of these two to represent the whole group, we'll assign the second root character to represent the combined group. So we'll change the parent of our first root to point to the second root. Otherwise, we'll change the parent of the second root to point to the first root. Now we are done with both the union and find implementations. We'll now go through each pair of characters for both our input strings. We'll zip these two strings so that we can traverse without using the index. Since this pair of characters have to belong to the same group, we'll assign them to the same group using the union function. And once we have gone through all the pairs of characters, our union function would have merged all the similar groups together. Now let's define a variable to store our result string. Now we'll go through each character in our base string, and for each character we'll map it to the root character of the group it belongs to. To find the root, we'll call the find function for each character. At the end of this, we can return our result. Let's submit it. You can see our solution is accepted. If this video was helpful, please leave a like and subscribe to the channel for.
yeah, man. To be honest, that just seems a little confusing. I mean, I could implement that, but I don't really feel like I'm learning. To be honest, I just thought the problem was really confusing to begin with, so I'm probably gonna skip that problem for today. So we're gonna do something different. Maybe we might just go back to our graph theory list. That was kind of an odd problem, I'm not gonna lie. Didn't really like that problem, but yeah, look, they got union find here, bro. Oh shit, it's right here. Lexicographically smallest equivalent string. That is a daily problem. Maybe I should just do it then. I'm just not sure. This confuses me right here. Like, maybe there's a better description and discussion. Solve this question by using a map and a set data structure. I don't understand how base string applies to this. Like, I get this part here. Okay, they're equivalent characters. Equivalent characters follow the usual rules of any equivalence relation. AA is equal to A. AB implies BA. Okay.
Hello everyone. If it was helpful, please leave a
I'm just not good with union find. Disjoint set is used to manage collection of disjoint non-overlapping sets, also called partitions and exponents. Whoops. To find determine the set. I've implemented union find before, not by myself, but I mean, it's just something that I got to get comfortable with, you know, like, oh my gosh, dude. Let's try and go through the code and try and understand it. Parent is equal to this, right? Define C, right? So we do, well, if C not in parent, parent C is equal to C, right? So we're just going up the tree. If C not in parent, then we make the parent to itself, right? So this obviously makes a parent to itself. If there's no parent, it makes parent to self, right? Come here and we do while C does not equal parent C. Okay, so while C does not equal parent C, so that means there is a parent. We make the parent of C equal to the parent of C. So we're going up the tree here, right? To find something, right? C is equal to parent C. Okay, then we return C. Okay. Now the union part is where we go, okay. So we pass in two things, right? We do P1, P2 is equal to find C1, find C2, find C1, find C2. Okay. If P1 is greater than P2, then we do parent P1 is equal to P2. Else we would do the opposite, right? P2 is equal to P1. The code seems pretty simple, right? I feel like that code is fairly simple, right? We're looking for the maximum here, right? We're looking for the maximum parent, right? P1, P2, find C, we find it, find the parent, then we check if the parent is greater. If it is, then we assign parent P1 to be equal to P2. To the parent. But why are we doing that though? I think really fundamentally all this comes back to is that we don't really understand what the problem's asking. S1, S2. Let's go back to that. Let's see if maybe AI can help me explain the problem. you were given two strings, S1 and S2, of the same length. Each pair of characters, the same index S1 and S2 are equivalent. Okay, I know that. Okay, I got that part of the thing. A third string, base string. You need to return a string where each character in base string is replaced by the lexicographically smallest equivalent character based on the equivalencies from S1 and S2. Lexicographically smaller character becomes a parent/root. Steps to solve. If P1 is greater than P2, then P1. Make the lexicographically smaller root the parent of the other. Equivalent pairs. P is equal to M. A is equal to 0. R is equal to R. K is equal to R. E is equal to I. R is equal to S. After building the group and reducing them, map to the smallest one. M. A. R. M. A. K. How do we get K? How do you get the output? PM. Okay. Meaning PM. No effect, right? Because we get the reflexivity. Symmetry could be A is equal to B implies B is equal to A. Transitivity A is equal to B, B is equal to C, A is equal to C. Man, these rules are so confusing, dude. Like, what? I think I learned about these in college too, but I honestly don't remember. If A, B, I believe this applies a transitivity rule here, where it goes. So this is where we're looping through. This part here is where we're looking through P and M, right? And then we're calling union C1, C2, right? Okay. Then we create our res array, right? We go for C and base string. Res plus or equal to find C. We would return res. So then we would find over here. We find the grandparent. We return the grandparent, right? Because the grandparent is always going to be the smallest value, right? So we get the smallest value here. If P is greater than V2, then we assign, I get how this is working fundamentally, but what I'm still confused about is just the transitivity rules here. That's what's confused me, but I feel like there's no... I get what it's doing though. I'm gonna add a note up here. I'm gonna submit it. I don't like submitting stuff when I haven't done it myself. But I need to come back to this. I do understand the union find data structure. I have looked at it before, but I don't understand how... I feel like this problem description is just kind of messing with my brain a little bit. I find the transitivity rule, the what you call it, the equivalence relations confusing. So we're going to do a quick problem, another problem. It's because I feel bad submitting that. Honestly, I feel kind of bad. I want to do another problem. But I also have to go to bed soon, so I'm exhausted. Let's find something with like easy difficulty that we haven't done before. Man, I don't know. What should I do? The island perimeter? This looks like a graph problem. We're gonna row times cold grid representing a map where grid ij is equal to 1 represents land, and grid ij is equal to water. Grid cells connected horizontally, vertically, not diagonally. Grid is completely surrounded by when there is exactly one island. The island doesn't have lakes, meaning the water inside isn't connected to the water around the island. One cell is square with side length 1. The grid is rectangular width and height don't exceed 100. Determine the perimeter of the island. Ooh, this is kind of a tough question. I feel like. Determine the perimeter of the island. So what is the perimeter here? Ooh, 1, 2, 3, 4, 5, 6, 7, right? 7 times 4. Ooh, but no. Damn. This is a tough question because... Yeah, I wonder how... There must be some sort of formula to be able to discover this, because everything is going to be different, right? You could have some that are 3, you could have some that are 3, you could have some that are 2. Right? Okay, so you don't have to run BFS here. They've already gave you the perimeter, right? So they've gave you the ones that are 1, right? They've already found them for you here. So really, I think what we have to run here is we got to run probably some sort of DFS or something, right? I'm trying to think here. Maybe some sort of DFS I can count, well, if you have 1 connected, right? If everything else is 0, you count as 1, then you have 3, right? But if you have 1 everywhere, you have 0, right? But if you're connected to 1, if you're connected to 2, technically you only have 2 edges to count. If you're connected to 2, you only have 2 edges to count. All right, so if you have 2 here, then you have 3 over here because you only have 1 thing over. Can you have 4? You can have 4 if it's 1 single island by itself. So I'm thinking we do, let's do for row, sorry, let's do rows is equal to grid 0. Cols is equal to, sorry, grid 0. This would be the length of grid. This would be the length of grid as well, right? So we want to, let's print our rows just to visualize it, print our cols, right? I feel like this is kind of a tough, easy problem a little bit, but it's all right. Okay, so if we go, well, for row in rows, and we go for col in cols, right? And we go, well, if grid row col is equal to 0, is equal to 1, then let's do like our total count plus or equal to 1, right? We have to, let's initialize that. Total count plus or equal to 1, right? So let's get rid of that edge case, right? So now if our total count is equal to 1, right? We can just return 4. Okay, this is our edge case here, right? Because if we have a single 1, that's the only time it's going to return 4, right? So my next intuition is that, well, we're going to have to loop through this, okay, and pretty much count using, I said DFS at first, but maybe we want to do BFS. We're going to have to count from that grid how many different ways are there to go. So we'd have to check its neighbor, right? If there's 1 way, then we can add 3. If there's 2 ways, then we can add 2. And if there's 3 ways, we can add 1. In this case here, in this example, we don't have 3. Right? Because if we had 3 here, we could be here and have here. Wait, can we have 3? I'm confused now. Can we have 3? Maybe not. We have 1 here. There must be an easier way to do this too, I feel like. It is a DFS problem. Yeah. I don't know. I'm doing it a different way, but I don't think it is an easy problem either. I think this definitely should be a medium, but okay. So we loop here, right? So I'm going to do, my intuition here is BFS. I know that discussion question just said DFS, but from collections import Q, right? We import our Q. Okay, we come here, we go while Q. Okay. We do Q is equal to DQ, right? And then we want to go, well, for row in rows, for col in cols, if grid row col is equal to 1. I don't even think we need the Q, right? Then we're going to run, we're going to have a helper function here. Like, let's do helper function. I don't even think we need a Q anymore now that I think about it, because we're not really adding anything. We can do find edges, right? And we pass in our row call, okay? Let's do edges is equal to row call. Then we do count plus or equal to edges, right? And let's add our count here, okay? So we create our find edges method here. Def find edges. That takes I'm gonna do it. That takes we want a row and a col. Have a row, a col. Okay. So then we would go, well, let's do a row, col, and a directions. Now I think about it, we need a directions array. Let's do directions is equal to, let's go up, down, right, left. Okay, so we would go here, up would be -1, so we go 0, -1. Down would be 0, 1. Sorry, it's meant to be the other way around actually. This is up, this is down. No, down is positive. What am I doing? Up is negative. We go, if we want to go left, we would have to go negative. -1, 0. Then, this confuses me. Right is positive, right? Left is negative. So then we go from here, we would go, okay, well, we would go, well, for dr, for new row, new col, in directions, okay, we would go new row is equal to nr plus row, new col is equal to nc plus col. Then we have to check if it's in bounds. Well, if 0 is less than or equal to new row, but is less than rows, and 0 is less than or equal to new col, but is less than cols. Okay, we're just checking the bounds here. Then, and grid row col is equal to 1. So we're only looking for stuff that it has, right? So if it's equal to 1, then we make our, I'm gonna call it our I count is equal to 0, right? We make our I count equal to 1. I don't think we're really gonna have any time complexity stuff here, so limitations because it's an easy problem. Yeah, so anything should be fine that we make. So it's kind of slow, but I don't know, that's right. I count plus or equal to 1. Okay, we do that. We come outside of the 4. Okay, and we would check, well, if I count is equal to 2, we want to return 2, right? Else if I count is equal to 1, right? So if we have one edge, then we would return 3. Else, if we have 3, I guess we can probably just return 1, right? Because there's no way we can have 1. I guess we could have 1. Oh no, yeah, 1 and 2. But if we have 3, 3 won't work. Oh, 4. Holy shit, dude. I count is equal to 4. Then we would return 0, right? Else, we would have to return 1. right? We would return the counters, add the edges, and then we would return our counter. There's definitely got to be some sort of error here, like import Q. We can get rid of that. And I did just notice an error. We need to pass in our directions here. Directions. Cannot access total count. Why is total count plus or equal to 1? It's meant to be 0, dude. How the hell did we get plus or equal to 1 there? Object is not iterable for row in rows. We need a range function here. In range calls. Row in range rows. Range calls. Got something wrong here. We got 5. Let's print what we're getting every time. Let's print our edges. You get 4, 8, 9, 10, 12, 13. How the hell are we outputting 5? So for the first one, we output 4. How the hell are we outputting 4? Oh, we're not resetting I count, I think. Oh, wait. No, we're not. We're only counting it once, right? We're only checking that. So we won't need to reset it. We're calling this every single block, right? So 4. This should return 3. We should only get 1. So we should return 3. I don't understand why. I don't understand. Is wrong. The condition doesn't actually check the neighboring cell. You're rechecking the current cell. Grid row call is equal to 1. Oh my gosh, dude. New row. New call. No way that was my issue. That was my issue, bro. No way. That's crazy. Alright, there you go. We solved it. Was an interesting problem, but yeah. We got there in the end. So appreciate you guys watching. I will see you guys tomorrow.